Welcome back to the course on superconductivity. Today we're going to talk about Young's modulus and Poisson ratio. We'll first go over the definitions of stress and strain, then define the Young's modulus and the Poisson ratio. The stress is defined as the force applied per unit area, while the strain is defined by the ratio of the total deformation to the initial length. Young's modulus is a mechanical property of materials that tells us how easy it can be stretched. It is defined as the ratio of the stress to the strain. Usually, Young's modulus is determined by doing a tensile testing. Basically, one can take a piece of material of defined size and apply a tensile load to stretch it until it breaks. While doing this, the stress applied and the deformation is measured. On the left-hand side, we can see the typical result of one of these tests. From 0 to the point 1, we're in the pure elastic regime, so where we can use the Young's modulus. From point 1 to 2, the curve is still following a rather straight line, but strictly speaking, some dislocation will move, inducing permanent deformation, and therefore it is not considered truly elastic, though Hooke's law and Young's modulus are still usually used in this area. Between point 2 and 3, we usually see a small plateau, which is the limit of the elastic regime, also called the yield strength. As of point 3, we're in the plastic regime where irreversible deformation will occur. This means that, for instance, if we stop applying the load at point 4, the material will shrink back, following the elastic regime curve. For our example, the sample has been irreversibly deformed of 0.2% of its original length. On the right-hand side table, some values of Young's modulus are given. Poisson's ratio is the ratio of the deformation of a material in the loading direction to the deformation in directions perpendicular to the loading direction. On the left-hand side graph, we can see that we apply a compressive stress that makes the material shrink in the y-axis. However, the material expands on the x-axis. There are different terminologies depending on the symmetry of a material mechanical's properties. Isotropic materials have the same mechanical properties in all three directions. Orthotropic materials only on two directions, and anisotropic have different properties on all directions. On the right-hand side, we can see an example of orthotropic material that is deformed equally in both directions, perpendicular to the load axis. To conclude, by definition, Young's modulus is the ratio of the applied stress to the measured strain of a material. Poisson's ratio defines the deformation of a material in directions perpendicular to the direction of loading. Young's modulus tells us how stiff a material is so that we know how much deformation will occur when we apply a given stress. Poisson's ratio tells us if and how much a material will expand or contract in the directions perpendicular to the loading direction. A material which has the same mechanical properties in all three directions is called isotropic, for instance metals. One where the mechanical properties are identical in two directions is called orthotropic, for instance wood, and one where the mechanical's properties are different in all directions is called anisotropic.